All right, hey everyone, welcome on in. Happy Saturday. We are going to be starting a new series here, Rust, with our Retrieval Augmented Generation. That means that we're going to be building, basically what enterprises kind of want. An engine that can take all of their corporate data or all of their documents or wikis, things like that, turn it into basically like a Google that can find all that information and then use an AI on top. Oh, I forgot about the AI part. We're going to do that part too. We take a large language model that can summarize the results. So they should probably diagram this really quick. All right, so let's do a quick little diagram. All right, so we've got a user prompt. What's a good user prompt? User prompt. What are the restricted LLMs that we cannot use due to compliance? Something like that, right? So this would be a very good prompt right here. I wonder, can I embolden that? No, I can't. Okay. So this is our input prompt. The user is going to input this as a prompt. What we need to do is vectorize this using an embedding. And then we need to take those embeddings and then throw that against a vector database, which is going to be an index of all of your corporate documents. And somewhere in there is going to be information about the restricted large language models that we cannot use. For example, models that require untrusted code execution, for example. Hey, Sergio, good morning. Happy Saturday. Good to have you here. We're going to be starting our Rust Retrieval Augmented Generation today. I'm really excited about it. Watching with my wrapper. Oh, cool. Quick fix. Really? Is it working? I had it up. Let's see real quick. Let me see here. Here we go. Is it working? Oh, hey. All right. So yes, it kind of is. It's kind of working. The chat box disappeared. That's okay. Let's see here. Test. Is it testing? All right. Let's try loading it here one second. Oh, this is neat. Check it out. All right. Well, you got the embed working part. At least that part's good and go. Okay. So let me get my windows in the right place. Nice. All right. Good to hear it. Let's see. I want to go back to where I was really quick. All right. So we're going to create sort of a diagram really quick of what our project's going to be. It's probably going to take us a week, at least a week. We need to build a lot of components. We Axum server with a router. We need to define a large language model, which we could run locally if we wanted to. We could do like a Gemma model. That might work really good. We're starting the wrapper. Okay. Sounds good. There's a lot of options here. So let's list out all the different components that we're going to need. Let's just list of components, and then we can draw them out. And we piece them together. Components. Did I spell that right? Parts. List of I can spell this right. Components. There we go. All right. So let's see. We're going to do, let's put this in. What do we want? Can I type that? No, I can't. Okay. Let's see here. Nope. Yes. Okay. What is this? Delete that. Get the next song going here. Okay. We need what else do we need? We need something here. All right. So we're going to need a web server. Ooh, it's pretty in purple. I didn't mean to do that. All right. We're going to make them pretty in purple. Here we go. So we need web server. We need a couple other components. Let's see. What else do we need? I think we need at least 5. Let's pretend we have 6 components. I don't know if we need them, but we'll find out. How's it going there, Prashant? Prashant, good to see you. Today, I installed NeoVim. Oh, nice. All right, you got some NeoVim there. It's really cool. Nice. And I have understand up to using plugins. Yeah, plugins are extra. I got a little bit of extra in there. So can you list top plugins that you've used for good productivity? My favorite is no plugins. To be fair, no plugins. I know it sounds weird. I know it does. So let's take a look real quick at so I don't use NeoVim, I use regular Vim. So Vim RC. Let's take a look here. So I have a very specific set of capabilities that I use to configure Vim, but there's no plugins. I do terminal colors for pretty colors if needed, right? Make sure I do no swap file. I have undo levels. I keep about 2,000 undo levels. We could go more than that. I enable smart tab and auto indent. So that way when you're writing code, it auto formats along with your lines with you. And then I add relative number, which you can see here on the screen. Right here, right? You see that it says 21 right there on the screen. Right over here at the left side of the screen. When you're moving cursor up and down, it keeps that number exactly what your current line number is. And then you can jump up. So if I wanted to jump up to color scheme groovebox, you can type 10 up and it immediately jumps to the line, which is nice. So there's a lot of neat little things in here that you could use. And then I have a few file format things that I use to help make the, guys, I like color. You like to have the color in there. All right. So let's jump back over here. All right. So what do we need for our retrieval augmented generation? All right. Retrieval augmented generation. Let's see. It's retrieval. Got the A and the E mixed up. There we go. All right. So retrieval augmented generation, which is RAG. All right. List of components. We need our web server, which is going to be Axum. We'll do like Axum. Right. We're going to do an Axum web server in Rust. Then we need an embedding. There we go. Which is going to vectorize our text. We also need a vector store, and we're going to be using Turbovec, which is a really fast, a really efficient one. It's really good. You detected it's a bot fixing it. Oh, okay, sounds good. Sounds good. Quick fix. What else do we need here? We also need a meta store and a full text search engine. So we're going to use, what do you call that? I'm going to call this a database. So you need to be able to store the data itself. Database, which is going to have, we're going to use SQLite. We'll use SQLite, and this is important. This is going to be a huge part of the deal. This part right here is going to give us our metadata, so we know where the original article came from, like what file or reference it is. And then we can do other information like dates, links, how do we get back to it? And then you also need to slice it up. So we need a schema. We need to define a schema. We can do a normalized schema. Which means that we have everything in its nice little components. So this is going to be some database design here, some schema design. What else do we need? I think we need at least one more component. I'm trying to figure out what that's going to be. What else do we need? We've got our web server, an embedding, our vector store, our database. I feel like we're missing something. Hey, thank you for the hearts. Appreciate it. Good to have you here. All right. So what piece am I missing? I know I'm missing at least one other piece. Let me see here. I wrote some notes. Let me go really quick into my notes. Embedding, database. That's it. All right. I think that's it. We did it. There's nothing left to do. Okay. We only need 4 components. That makes it really easy. Here, this is great. Okay. So we can go through the workflow. What does it look like? So we've got our prompt. And let's build the workflow really quick. So our prompt is going to be, let's see, number 5. We're going to go prompt to the next phase, which is going to be something else, right? So then we need to vectorize it. So here, let's do a quick little vector here. I want this. Yes, thank you. All right, so we need to vectorize with the embedding. We need to turn the words into numbers. Embedding. So this will be words to numbers, right? And so that's going to put it into a bunch of different numbers. Let's see, and make it kind of look like, I don't know, this will be kind of like a bunch of numbers here. So we'll type in the numbers to make it easy for us to see what's going on. 0.34, 0.1, 0.7, and then we'll go 1.5, something like that. 3 kills without dying. Oh, how's it going there? Jaguar Law Gaming, welcome on in. Good to have you here. A reward for our team. Oh, wait. What? Wait. I do not know. I do not understand. What are you saying over there? -5, maybe? No, 0.4, I think. That's 5. -1.1. All right, so that's just a bunch of numbers and so on, right? Got a bunch of numbers there. So this is our embedding here. Let me kind of make that a little bit easier to read. There we go. Okay. Then we need to throw this into our vector. Oh, and it also goes into multiple directions, right? So we need it to go here at the same time, and it's going to go over to our database, save data. Wait, well, no, we don't actually have. This is all right. Let me think this through. We need our data sources, right? We need all of our data sources. All right. So this is our vector, and then let me create a series of things. So this will be our vector DB. There we go. Bro, I love Excalibur. Is it great? I like it too. It's good. Yeah. You've got a good eye. Yep. This is Excalibur. You got it. All right. We got our vector database here. Thank you for the hearts, you guys. And then we also have our standard database. So SQL database is what I'm going to call it. So this is our data store. And this is where all of our document data is going to live. All of our document data is going to live there. And I suppose we could have another thing, which is our original files. Let's see, original documents. Original documents. There we go. So we've got vector, SQL, and original documents, which are probably just like flat files. We'll just do flat files. Easy. Very, very easy. Okay. So we vectorize our data on the prompt, and then we also need to load in our data. So let me see here. I need to create like sort of another direction. So I'll go top down is what I'll do. So we've got all of our documents here. Let's see here. Documents. So core documents. So original, is that what I wanted it to be? 1 second. Yeah, okay, that's what I thought. I want this to be attached. Attach this to this, please. There we go. Okay. Original documents. There we go. Which is going to be things like, I don't know, wiki, PDFs, things like that. Right there. And then we need to do the same trick. So we need a multi-direction here. We need multiple directions. We need to feed data into our database and generate the indices, right? So that way when we do a prompt and we do a lookup, it'll be real fast, like really fast for that lookup. Then we also need an LLM summarizer at the end. So there's a lot to this. I haven't really thought how much we're really going to need to do here because there's quite a bit, right? So we've got our original documents here, which is going to save data here. And let me kind of just move this around. So then we can, do we want to make this separate? I think we can just keep the original documents up here. So it's a little bit better. And then we're going to have number 5 go over here. So we're going to save the documents, and then we need to slice them up. The reason why you want to slice them up is because you have a very big document and you try to vectorize that giant document, you're going to get like a really fuzzy vector embedding output. Because if you create a single vector, which is a one-dimensional array, right? You have to do a one-dimensional array for that document. And you're going to get so many numbers based on the dimensions of the embedding. So like say it's 1024, for example. That's the maximum numbers that can be associated with the document. If you just shove in a giant document and you do the embedding across that, it sums or it averages across all the words, all your words in the embedding. And then it creates basically something that could create a similarity if you do a search against it. It will have too many words and it'll be too fuzzy. It'll be way too fuzzy. So you will have a hard time ranking the outcomes and finding the right documents. So ideally what you do is you slice that document up and then you find parts of that document that are relevant to your user prompt. Like what are the restricted large language models that we cannot use due to compliance reasons. Right. So that's where we need to do this. We need to slice this up. So this would be like slice, or maybe, what do you call it? Is slice the right word? I think it's called chunking. Chunk articles into slices so that our vector index can be higher quality. Higher quality. There we go. Hi, happy Sunday, Kunal. Good to see ya. Welcome on in. Good to have you here. We are starting the Retrieval Augmented Generation because everyone asked for it. So we're like, okay, let's do it. Let's make it happen. All right. So what was this over here? So what were we doing? We were doing something over here. Okay. So we got our vector database. We've got our original documents. We've got our SQL. And we want to slice this section here. Let me put this on multiple lines. Right there. And then we throw those into the databases. So we've got a lot of work. We got a lot of work ahead, right? So then we've got our vectors. We're going to search here. And then we'll do a full text search simultaneously. And we'll get 2 rankings, right? We'll get 2 rankings. So we'll get probable answers as the output of what documents are relevant. My Sunday is about to start. I'm from the future. That's right. I forgot. You're over there on Sunday. You're almost Sunday. Yeah. What is it? 8:30. So it is 9. Is it 9:10? 9:10 p.m.? Well, or how late is it over there? Okay. So we've got our workflow cut out for us here. Do you use LangChain for RAG? You could if you wanted to. You could. We're just gonna write a regular app. We're gonna keep it simple. We're gonna keep it really simple. Yeah. So we'll just have we'll have a web server, Axum in Tokyo. Axum, Tokyo Axum. Then we'll have our vector embedding, which we need to decide on. Right. So we do need an LLM. We need to decide on an LLM. So LLM to summarize. Make it summarize there. There we go. So we need to summarize it. Yes, it's 9:10. Oh, I got the math right. All right. Hey, that makes me... that means I can add numbers. That's all it means. Hey, good job. You can add numbers. All right. So original document, chunk articles, and then we get our rankings, right? We get a bunch of possible answers. So we get a sorted list of docs. We get a list of docs here. Grab this. All right. I want to actually... Is that good? Yes. Okay, there it goes. What's the difference between LangChain and LangGraph? I don't know. Let's ask the Gemini here. LangChain versus LangGraph. What's the difference? Yeah, smart 911 now. Oh, you smart. I know. Yeah. Here we go. Primary use. LangChain, data ingestion, retrieval augmented generation pipelines, simple sequential chains, tool abstraction. I mean, that's kind of what we're doing right now, right? So we'd want to use LangChain for this. Complex agents, multi-agent orchestration, loops, and stateful workflows. Okay, so LangGraph is for AI agents. LangChain is for data pipelining, it looks like. Stateless path-through, basic, state handling, human in the loop, difficult to implement cleanly. But if you have LangGraph, you could add human in the loop. First-class citizen. Interrupt and resume nodes natively. All right. Is it better to write code from memory? And if you ask AI also, then instead of copying the code, typing is better, I think. Yeah, all right, so there's multiple ways. All right, there's multiple ways. All right, let's talk about learning really quick. This is one of my favorite things. All right, so there's 3 stages of learning, or three different kind of things that you can do here. So one, and these are ranked in order, right? So you want to do this at the top. This is the number 1 option. All right, you want to do this. All right, write code by hand without getting help. No help. So it means that you have to do a lot of extra work and effort, and maybe you have docs locally that you can read. You can read, right? So you can read the docs. That's it. This is the number 1. Number 2 is you can see write code by hand and ask help from AI when you need it. That's number 2. And then the worst possible way is ask AI to write it for you. Actually, that's probably item number 4, really, to be honest, because you're not learning anything at that point. There's nothing you're learning here. But there is one more that I believe there's one other option that you could do. Just follow along. Follow along and retype something that was already written. There you go. So this is number 1, number 2, number 3, and number 4 is the worst, right? So if you want to get the best possible knowledge, write the code by hand without getting any help and read the docs, because it's going to be a struggle. It'll be a struggle. Hey, good luck givers takers. Good to see you. Happy Saturday. Welcome on in. Good to have you here. Better to write code from memory. You got it. I got you. Wow, cool. Is it Kunal? All right. Good to hear. Hey, Griff. Hey, Griff, Vibrantal. Yo, Griff, Vibrantal. Good to see you. Sup? Good to have you here. Cancel mapping. Yep. One's genome and blood pressure medications benefit for tailored medical treatments and reducing... Wait, what are you talking about? Hey, Big Data Jay. Good to see you. Welcome on in. Happy Saturday. Good to have you here. All right. But you've heard LangGraph used with only Python and JavaScript. Yeah, because it's more of a scripting type thing, right? Because you're going to orchestrate pieces together. It doesn't need to be like mega scale. Hey, top 1% engineer, good to see ya. Welcome on in. Happy Saturday. We're going to get started on our Retrieval Augmented Generation. We've got our basic plan here. We've got a basic plan. We've got all of our components. We're going to vectorize the data, and then we've got our original documents, and we throw them into our stores. We're going to have VectorDB, which is going to be Turbovec, and we're going to use SQLite for a SQLite database for our metadata and data slices. And then we are able to get our output, right? And that's going to be the answer. So the LLM will answer here. So the final output. So we rank all documents here. Let me get this, make sure this is on the right side right here. There we go. There we go. SSH, good to see you. Hey, Steve, huge relief hearing that there's a lot of advantage for all these struggles. Happy coding. Yep, there is. It's a lot of advantage. It is. You remember. Copy and paste next chat. Copy, paste next chat. Immortality. Hey, Griff, I see what you're saying. Are you making your own RAG system? Yes, that's what we're doing. We're starting it today. Our own Retrieval Augmented Generation engine today. For the most part, we're going to piecing together several components, making it accessible via a Docker container as a API. So you can build an API. And this is going to be a really good one. Not like a little tiny one. This is going to be something that you can build that's going to scale to the stars. You could make a whole business off of this. This is going to be a legitimate, like, full-on business. You could think about doing all 4 steps with going through. Oh wait, I would think that doing all 4 steps would be thorough. Yeah, if you could, like, so where was that at? It was around here. Okay, yeah, it'd be pretty thorough. I think so. I mean, really, it comes down to learning as much as you can yourself, and then getting a little bit of help by searching, and then following along, retyping something maybe. And then just not doing anything at all. No work at all. Okay. Or you can use it as a reference, right? So you can see what the AI would write, and then you can do it yourself. Something like that, right? Okay. So let's get started. So I've got an empty directory here. Cargo init. We're going to call this our... What do we call this? We should give this a good name. It should have a good name here. A good one. Can you use your GPT? And will it be a CLI, TLI, or web GUI? Oh, you know what? We could even add a web GUI. I didn't even think about that. I didn't even think about a UI. Let's see here. Let's see if we can do a UI. All right, then we'll have a UI. So that way you can easily, like a web UI maybe. Web UI. For happy user. Okay. So now we've got all of our components. Web server, which is going to be Tokyo Axum. Embedding, which is going to be, we're going to say, oh wait, hold on. We got a vector store. We need an embedding model, right? And then we can use the embedding to store into our vector store. And we're going to use a database, which is SQLite. LLM to summarize, and then a web UI for a happy user. There we go. I like it. I like it. Hey, Kurt. How's it going, Kurt? Good to see you. Is coding really dying? No, well, coding by hand is, which is what we're doing right now. I don't know. It really is, because you can just ask the AI to write it for you. There's no point. There's no point to code it by hand anymore. It's like we're punch cards now. That's what we are. We're punch cards. More orchestration in views. Yes. Less code writes. Yep. New developers usually vibe coders. Yeah, they are. You're right. Most coding done through prompts. Less productive, right? With more prompt, more productive, but less stable when it comes to scale. Well, it's getting better. Yes. And so as an engineer, your job is to figure out what needs to scale. And then you speak with the AI and describe it, how something is going to scale and stretch. GUI and Rust. Oh, we should do iced. I wonder if we could do iced. Yeah, so we could do Rust iced, right? Iced cross-platform GUI library, which is the creator, which I found out, the original creator of Electron, which is the desktop, multi-platform desktop app that is, pretty slow. If you run with iced, though. Whoa, there we go. Hey, Erdem, good to see you. Happy Saturday. Welcome on in. Let me see here. Let me go back over here really quick to our notes. All right, so web GUI, we could do something like web UI/iced. Yeah, look at that right there. I like it. Okay. What should we call this? We should call this something. We need to come up with a good name. Let's brainstorm. Thanks, man. Love you live sessions. Oh, it's always Kurt. Hey, thank you so much. Appreciate you. Yeah. AI gonna write all the code for us. What we're gonna do though is we're gonna write it all by hand. As you can see right now, there's nothing in here. There's no code here at all. We're gonna be writing code from scratch. So cargo init. We need to. Can I just do period? Yes. Okay. So we're just gonna call this Retrieval Augmented Generation Axum Rust. If we have a better name, we'll come up with it later. All right. Cargo build. All right. There we go, right? Cargo run. It's going to be hello world. All right. Yeah, as you see it, we're starting from zero now. How's it going there? Wrap API. Yeah, well, basically an API. Exactly. We're wrapping it up. You need to set up Spoken yesterday. Oh, right, Erdem. You need to set it up. Yesterday you exhausted while you're trying to run Spoken. Well, you got to run it in the browser. If you run it in the browser, it works. I thought you will do in UI.js. Oh, we could do that if you want. Do you think, Kunal, do you think we should do it? I mean, we could, can we use, is this JavaScript? I think it is. It's like React, right? React, does it support React? Hold on one second. All right. Iced Rust support JavaScript React. I think it does, right? I think Iced itself does not use JavaScript or React. Oh, wait, but it does have experimental WebAssembly instead of using JavaScript React components. Oh, okay. If you're looking for a Rust framework strictly to JavaScript React or DOM, you should consider alternatives. Dioxys and U. Oh, I forgot about U. U's been around for a long time. So, all right, you guys, we've got plenty of time to think about this. What should the UI be written in? Hey, let's go in there. AW9Q. Good to see you again. Welcome on. Honestly, large language models still make some serious mistakes. They do, right? They still make some areas that are not accessible for AI to train on. Yep. There's a lot of corporate behind-the-scenes infrastructure, source code that's proprietary IP owned by enterprises like mine that the AIs have never seen. Or, well, I suppose, I mean, it's possible that they've got some nefarious ways to achieve acquisition of that. U is better? You like U better? Okay. Dioxys is a bit more mature, but U is better. All right. Let's see, U Rust. Let's take a look at this. A framework for creating reliable and efficient web applications. All right. That's pretty tame. That's a pretty tame statement. Let's see. Oh, interesting. Okay. Oh, interesting. So you write all of it here, and then is there a run? We've got it running in the background. Hello world. Okay. Interesting. So you basically have your DOM. You've got your DOM, and you're writing it all directly in Rust. That's really weird. I think that's really weird. You can run it in a browser, but OBS does not show the instant speech. It does show the text-to-speech area, not speech to text. Okay. So Erdem, maybe what we could do is, so it's really straightforward. It's supposed to be. You should be able to just follow these instructions here. Let me see. Start here. click this link right here, this link, it's going to cause my subtitles to stop working. Right, hold on a second. My subtitles will stop working here. However, if I have it running here, as you can see, let me put caption mode here. Okay, so now we're talking. Now you can see on the screen what I'm talking, right? All the words right here. So what you do is, now that you've got the words showing on the screen here, you can also change you can make it, different. Oh, wow. Oh, hey, if you guys are still there, my Chrome browser just crashed. Whoa. Okay, let me get that back. 1 second. I'm going to hide the screen. Let me see. Well, actually, Chrome. Let me see if I can get that back. Let's restore. All right, it stopped all the music and everything. All right, ignore for now. All right, I'm gonna stop bothering with that for now. That definitely caused a browser crash. Whoops and doodles. Okay, let me see. No, I want. Oh wow. Okay. Ooh, let me click over here. Okay. We'll get the music going. Let's get the next song going here. Try this. Here we go. Perfect. Okay. All right. Whoops. I got everything back now. I'm sorry. Hey, Erdem, it wasn't your fault. That was my computer being weird. It's not. That never happened before. It never happened before. So it is pretty straightforward though. All you do is you just follow the instructions. You just click the link. You're done. You did that first part. Step 1 done. Keep that window open. Step 2, you're going to follow the copy instructions and add it as a browser source. Easy. Done. Easy. Hey, Moldy Cash. Good to see you. Welcome on in. Happy to have you here. All right. So where are we going next here? So we've got our web UI looking good there. All right. What was, this was going to be, let me see here. 1 second. Yes, there we go. Okay. All right. Everything's back up. Everything's back up now. You were thinking about starting with React Native because your JavaScript is about over. If you can contribute to make your Rust mobile app if you want. We could go mobile. We could go mobile. All right, so cargo add, let's see, add SQLite. Is that what it's called? We need to add Turbovec, SQLite, Axum, and I think that's it for now, right? Are those the things that we're gonna add? Oh, Tokyo. We need to add Tokyo. Let's do Tokyo. Tokyo. Okay. Then we add Axum. All right. Good. So far, so good. SQLite. Hey, there we go. All right. SQLite. I think. Is it? Did I get the right one? Yes. Lib SQLite 3. Okay. Good. We got the right one. Perfect. Okay. And then we did Tokyo Turbo. We didn't do Turbovec. Yes, do Turbovec. Turbovec, I think. Right? All right, there we go. By cargo. Toml. There we go. All right, so Axum, SQLite, Tokyo, Turbovec. All right, this is a good start. This is a really good start. Not now, on future, Ken, if you want. Yeah, so that sounds like a good plan. I like that plan. Kunal, good idea. It'll be good practice for me because it will be my first very big project. Ooh, hey, I like that. That would be a really good one because this is going to be a very powerful engine. I intend this to be mega scale. Like this is something that you would throw into a very large scale system. You could even use it as a multi-tenant infrastructure to make a business out of. And it will work real well. Real well. Okay. So let's look up the documentation for Axum really quick. Let's see here. All right. Let's do some Axum really quick. We should. What do we want to do here? I also want run Bacon. We'll run Bacon as well. Do we need to install Bacon locally? No, I already have it. Bacon. I have it right here. Perfect. Okay. We'll just type Bacon. See if it works. All right, building. We're building. Yeah, there we go. We're making it work. Damn. Hey, it's going to be great. I think it's going to be great. Okay. So let's keep going here. So we've got our Turbovec, Axum, Tokyo, We don't have our embedding yet because we don't know what that's going to be. We have our database SQLite. So we can focus on some of these components later. So we've got a big to-do list. This is going to take a while. This will take a while, you guys. All right. So by readme.md. Okay, so this is our RAG in Rust with Axum. Oh, we should also add Docker. So we need a lot of things here. All right, so let's get our to-dos. To-dos. All right, so we're gonna need a lot of to-dos here. Okay, so we need web server routing, the Axum. We need SQLite, DB schema. Oh my goodness. We have to do a whole schema. By the way, how will you connect your GPT to mobile app using API or something else? Oh, right. We could do it a couple ways. We could do blocks.ai, which will allow the connection to route in to your device wherever it's hosted. So it's a really good approach, right? We could do blocks.ai. We could do native PubNub, right? We could communicate through PubNub directly. So that will also be a good option. We could do, there's some other approaches. So I'll think about it. I'll think about what the good option is to make it accessible to everyone, right? I think that's a good idea. Okay, so now what do we need next? We need the vector embedding, which I don't know what we're gonna do here. We haven't decided. We don't know what the component. I kind of want embedding Gemma, but that might be a bit much. I think we should use a smaller, simpler one. How's it going there? Arsalan, good to see ya. How are you? We're doing great. Thank you for asking. Good to have you here. Happy Saturday. Welcome on in. We're building a Retrieval Augmented Generation now. Starting a brand new project. Today, it's brand new right now. We're getting started with it. As you can see, it's all empty. There's nothing here. There's barely nothing here, right? Vi source main, right? That's it. We only have hello world, right? So if we say cargo run, all it has is hello world in it. Although we imported all the dependencies, so there's quite a bit. Native will be great because we can build iOS and Android later. Ooh, yeah, right? So that's why I thought like Iced would be a good candidate, because I believe it does support mobile, right? So iOS, yeah, feature-rich iOS and tvOS if you wanted. Android, supports Android. Cross-platform GUI written in Rust using ADB to debloat non-rooted Android devices. So there you go. There you go. And you can save it as a desktop app too. So that's why I thought Iced would have been a good option, because it's real fast, right? It's got some really good performance. Bro, have you created your first small project? Oh, you've created my small project with 500,000 parameter model. Whoa! From scratch using your own encoder, transformer, and large language model. Now I want to go advanced. Did you really? Oh, that's great. That's really fantastic. So where do you want to go next? You did some generative AI. Have you done, so what I want to do next is, we've done previously on stream, we've done generative images, right? Making things pretty. Like generating images. So what was it? We built our own model from scratch. What I would like to do is try a different approach. I would love to go into diffusion. I want to do generative AI through diffusion. You want to make agentic models and a RAG system? Ooh, hey, all right. Yeah, there you go. So we're doing the Retrieval Augmented Generation now, which is almost a whole other discipline, really. It's like a component that lives next to AI, right? It's a way to interface and interact with AI directly. Next month, your plan is to do Fast API. Oh, nice! That's a good one. All right. You're gonna use Ollama and DeepSeek 12 billion parameter model. You could if you wanted to. You could. That's a big model. All right, web server. All right, so we need to do our routing, right? So our controller. This is the controller. SQLite schema, vector embedding. We need to UI, Iced, or other. right? So we can do iced. Then I need, we got a SQL, vector store. Vector store to disk, which is going to be Turbovec. We've already decided on that. So I think what we should start with is our Axum web server with Tokyo, right? So we got a bunch of to-dos here. All right, this is going to be a big one, you guys. This is a big one. So we already have our starting point here. So let's Google Rust Axum. Let's get this going here. Let's see here. All right. So we need to, I also want to use anyhow. Let me do anyhow really quick. Cargo add anyhow. I really like anyhow. So we can do use anyhow, I believe. Let's see, it's bacon. Let's get bacon going, you guys. Let's get some bacon going here. Okay. Resize pane dash D 10. All right, perfect. Bacon. All right. Unused import. Good. Okay. Resize pane. Resize pane dash up 5. All right. Good. There we go. I like that. Thank you for the party poppers. Can say project non-product. Oh, well, I think this is gonna be. What we're gonna do. We're not gonna make this a project. We're gonna make this like a full production ready system. Oh, I forgot to add Docker. Let's do that. Right. So we want to make this full production ready. This isn't gonna be a toy. This is gonna be real. Docker. Right. So we're gonna Docker container, or maybe Podman. You know, whatever you want to do there. Whatever's your container system of choice, but your container orchestrator of choice, because the container libraries are already on your computer. You don't need to worry about that. Hey, how's it going there, Zetify? Good to see you. Ooh, welcome on in. Happy Saturday. We're doing a RAG system today. Retrieval Augmented Generation in Rust. Rust with Axum right here. All right. You also give it your best. Nice, Kunal. Nice. Good to hear. Docker, web server, SQLite database, and schema, vector embedding, which we haven't decided yet. We're going to use, I don't know, like Word to Vec maybe, or something like that. Something simple and clean. Vector store using Turbovec, and then maybe a UI, right? A UI. Let's double check. What are we missing? Database, vector, web server, embedding, right? 1, 2, 3, 4, and then an LLM summarizer, right? Then we need to choose our LLM to answer the user's prompt. All right. Perfect. All right. We're on the right track now. Can't fix it. Try again, but send message in Twitch. Okay, I'll try it. Test. Okay. To make your Rust GPT go live on mobile phone. Ooh, hey. Kunal, yeah, that would be a really good one. That would be very impressive. Okay. So where do we want to go here? All right, over. All right, use anyhow the results. Oh, I want, wait. Results. There we go. All right, results, which is going to be empty. Right? Is this the right way to do it? No. Do result. Can we just do that? Expected at least one generic. Right. I forgot how to do this. 1 second. I was pretty sure it was this. Right? Like that? Oh. Okay. We do that. Argument missing. Oh, right. What if we say result empty? At least one generic. Fine. How about that? See, look at that right there. Weird. Look at the Rust go. It's going on its way. Getting deep into Apache Arrow for storing data in C++. Nice. 10,000 rows of data. That's a pretty good start. C++ a week ago. Very good. Very good. Zitify. Very good. Yeah. Greetings from across the pond. Hey, Squirrel Sniper. We're starting the RAG. We're starting the Retrieval Augmented Generation today. How's it going there, Liminal? Good to see you. Happy Saturday. Started V8 engine. Ooh, remember the V8. V8 is Chrome's engine, right? A little bit API tomorrow with promise and more. Sounds good, Kunal. Sounds good. I like that. All right, so we've got our starting point here. Let's go back over to our docs. All right, so we are going to use Axum. We're going to get some routing, JSON, and router. Is this a good starting point? Is this the best one? Axum's been around for... I used Axum 2 years ago, and it was amazing. And I'm just wondering if there's any updates. So let's look at the README here. It says the README hasn't been updated for 5 years. So there might be something better here. Are there docs? Let me see here. Let's look this up really quick. Rust Axum docs. How about this? Okay. Yeah, there we go. This is what I'm looking for. Okay, perfect. Get async hello world. All right, so we need to do our Tokyo main here. So this will be our Tokyo main. Tokyo colon main, like that. Okay. This function async. Do that? No. Yeah, async function. Here we go. All right, async function. Redo. There we go. Excellent. All right, good. Should you learn RAG in Python first? Yes. I think Python first is always a good option because you're gonna run into a lot of mistakes and problems. We need to say use Tokyo maybe? No. We don't. Tokyo main. Did I do this right? Tokyo main. Async. Then. Oh wait, Tokyo main might not want anyhow. The default runtime flavor is multi-threaded, but the RT multi-threaded feature is disabled. Do we need to get something extra? Okay. We have to do this here. Okay, 1 second. Let's open this. All right, cargo add. All right. But now it's green. Hey, that was it right there. Just a little bit of dependencies is all you need. Okay. So we got our Rust result, our Tokyo anyhow. All right. Looking good. We're on to the right track now, you guys. Thank you so much. You motivated you to code more. All right, because I was so lazy. Hey, all right. Isn't it great? Coding is a lot of fun. It's a lot of fun when you do it yourself. Right? When you do it yourself. Hey, how's it going there, SurfTube? Good to see you. Happy Saturday. What's going? Any short intro of it doesn't disturb you? Yes. Okay. So we are... Oh, I see you working over there. Quick fix. Testing. Test. Okay. So yes. All right, SurfTube. We are building a Retrieval Augmented Generation, so a web server, basically. And it's going to include full text search, vector search, and chunking. And then we'll basically be able to grab a user's prompt. For example, what are the restricted large language models, right, that users asking the system to get information? The restricted LLMs that we cannot use due to compliance, right? So that'll be one of the prompts that the user sends to the web server. The web server is supposed to use all of these components: Axum, Tokyo, Turbovec, SQLite, and then an LLM to summarize. And it will vectorize the text, search the databases, which we have 2 different database searches, so 2 different indices, and it will grab the most relevant documents and return the answer. All right, the answer is Quinn, and there's another one in there. I forgot. And then another one, right? Something like that. So that's what we're doing. How's the girl? Van Cheek. Hey, Van Cheek, good to see you. Hey, Steven, today create a Phoenix Janta party website. I don't know what that is, but it sounds fun. It sounds fun to me. What mobile app? And with mobile app, nice. Hey, Venom, good to see you. Happy Saturday. Welcome on in. All right, so we just did an intro. How was your summer? Wait, hey, Scott. Hey, Scott, how's it going? Summer so far is just started, for as far as I can tell. It just started here. So far, so good. Okay, so we have our plan. Let me close this here. Okay. Now, let me check. We need to go and read our docs. We're going to get our Axum router, get, and a router. Okay. Routing router. All right, so use Axum, : Here we go. And we want a routing get and a router. Okay, like that. Okay. And then we're going to build a new router. And then we're going to add into it. So this is, do I want it to be this way? Here, I want it to be this way. This is the way I like it better. I like this approach. This is cleaner. This is a lot cleaner. I want this right here. Much, much better. So you can see all the routes ahead of time, and then you can just drop down when you're ready. I like that. Okay. Let's do this here. All right, so, where do I want to do this? All right, so we'll say let app equals, this is router new. Okay, it's just a simple straight up new, and then we start adding routes into it. There we go. Period. This is going to be route / so this is root, get root. Do we execute it? No, we don't. We just get the root. Okay, perfect. Like that. And then we could do root here. And then we define a root. So let's go async function root. And what goes inside a root? Oh, we don't know. We don't know yet. Okay, what does it want? Async function root. So this isn't fully there yet. There's a get. There's a dot post as well. You could do that. That's interesting. Right there. Steven, my logic from your A53 to S26 Ultra, you expected Milk Lion. What is that? I don't even know what that is. Single threaded, allowing the ingest of 4 to 5 times the amount of raw telemetry. Well, that is a ridiculous amount. It sounds ridiculous. It's hot here. Oh, is it 43? Well, you know what? It's very cold here. It's like 19 or 18. Let's see. Current weather. Let's see. Weather in Celsius. All right, let me check this. I'm gonna run it over. So it is 14 here. It's 14. It's not hot here. SurfTube, that's really nice. All right, sounds like a good project. Yeah. Sounds good. Learn and enjoy and have fun. Thank you. Appreciate it, SurfTube. Are you a pro level of coding? Yeah, I'm pretty good. So those of you who are new here, my name is Steven Blum. I'm CTO at PubNub. I've been doing this for about 25 years now. We've got a company that I started many years ago. We raised a lot of money. We've got over 1 billion devices on our network right now, right? Doing in-app communication. PubNub is the company name right there. PubNub, right there. You're studying using Node.js and Bun. Hey, all right. Damn, very low, 14. It's cold, yeah. Can I work for you from home? Yes. Wada Wada. Absolutely, Wada Wada. Yes, we've got an open role. Let me see here. PubNub, just type in PubNub careers. I think we still have, we've been filling positions. We've been filling all the positions. All right, so we've got one left. We've got one left open position. I'll put it over here on our Discord. Go to link share. There you go. It is on our Discord if you guys are interested in the job right here. So we're looking for a Rust engineer. What are your thoughts about my past chat comments, Erdem? AI can write a great website or a mobile app, but cannot write a great AI agent or RAG system. Well, you know what, Erdem? It can. It can write a pretty good one. It can. I know. It's already good enough. It is. It really is already good enough. It really is. Let's see. Wada Wada. Oh, okay. So Wada Wada, you probably need to get some experience in. You know, a little bit of experience first. Just a smidgen more of experience there. Is there any work I can do? I would like to be able to. None of the teams, I've talked to the teams about it. AI can do everything. I know, right, Venom? It can get really good. Now, here's the thing. Can it build the most insanely optimum system? Probably with a lot of effort, yes. However, a human can do very, very good job at creating the most efficient system. Here's the ultimate answer. Check this out. Do we need that level of performance for every type of software? No, you don't. You don't. I know, Erdem, I know. I know, it's crazy. AI can do it all, you guys. AI can do it all. We're gonna write it by hand though. We're writing it by hand. All right, did I do this correct? I need to get this the correct syntax here. All right. Cannot infer type. Why not? Why not? App is equal to new router. Did we do this correct? Is this correct? This looks correct to me. App, let app equals new router. We've got router and routing get. Do we have that here? Router and routing get. Yep, we're good to go. Okay. We've got this. How about we delete this and just go here? So it's a little bit simpler. Must be a known type at this point. I mean, it clearly is because it's getting data back. Let's see. I'm just following the instructions. I'm following the instructions. Yes, humans can do the exact work. They can. You got it. You're going to be next, Sam Altman. Oh, water. I don't know about that. I mean, Sam Altman, he's done some startups and things and then some good investments. I don't know how good of an engineer he is. I'm mostly focused on software and architecture and design and science and AI, artificial intelligence. I love all the algorithms. I love all that stuff. I don't know how much he's into that. I'm different, maybe. Someone guide a professional coder for a new coder. Like it's difficult. Kunal, the AI, it's going to do what you ask it to do. And so if you ask it to do something silly, it's going to do something silly. Right? It will. SurfTube AI. Yep, exactly. It's AI right there. All right, so we need to figure out what's wrong here. What's wrong with this? All right, so what we could do is it's going to give us a suggestion. See here. Router. Okay. Why does it want a generic? I don't want that. I don't like that. I really don't. Router. All right. Help if this is intentional. Oh, it's unused. Okay, so it's just a warning. Here we go. Let app. All right, green. All right, that was it. That's all it wanted. Fine. Okay, the docs are outdated. No problem. We can deal with that. About me, old coding is far better than AI. Hey, Venom, is it great? It's like we spent all these decades, right? We spent many decades honing our craftsmanship over software engineering and code and building it such good ways. It's just so satisfying, right? We have great structures. We have perfect level of indentations. We keep our code clean and simple, right? And now all that's gone. It's gone now. The AI can just write it. And does it matter that it's well written? No. The only thing that matters is that it compiles and it works and it does exactly what we need it to do. The craftsmanship is gone. Goodbye, craftsmanship. It's gone now. Did you notice? There's no more craftsmanship. The AI took it all over you guys. It's gone now. Hey, George, good to see you. Welcome on in. George is the top #1 gifted membership person here. Thank you. George, thank you. Appreciate you being here. Good to have you here. About me, you got it. Venom. So, Squirrel Sniper, Steven, my C++ is optimized down to just 15 assembly instructions per sample? What? The CPU can easily ingest 200 million samples a second without breaking a sweat. Wow. Yeah, I could see that. For sure. All right, so I'm getting my root, but it would be nice to be able to also get information. Should we do a post? We should do a post. Let's get a post going in here. I want our root to be a post. Foo.post. Yes. So let's do our root. And I want this to be a post. Post, right? Can we do that? A .get or .post. No. Can we just do post like this? We didn't import post. So we have to do this. Post. Right? Is that good? Okay. So now this will be a post. So we can pass in. Or would it be better if we just allowed a get? A simple get. Because it will include the prompt itself. The prompts are usually pretty short, but maybe we can make it a post. Let's just do a post because I think that will be a little bit more straightforward. All right, so let's see, post here. There's a body, app router new, get JSON short, right? Async function JSON value, don't care about that. Plain text, don't care. Let's see here. I would love to be able to get the post going. All right, body. How about body? Let's learn how to do this. Shared state. Oh, we do need this. So this is something that we need. We do need this. All right. This is something that I know we need for sure. So here's our app state and our shared state. Okay. Right here. This is very good. All right. Exactly. All right. Venom. AI reacts differently as a person depending on how much code. All right. So, yep. Pro coder can find mistakes. They sure can. How much time left for the stream? We've got about an hour. We got about an hour left. Hello, Stephen Bross. Good to see you. Happy Saturday. Hey, everyone. All right. What's your job? Oh, Wada. My job. I started this company called PubNub over a decade ago. It's an API for communication, built-in app communication, right? So for call centers, transportation delivery, like you order food on your phone, right? Order some food on your phone. So if you know Swiggy or TalkShop Live or Ticketmaster, they use our technology to allow multiple users to communicate with each other, usually over the phone or with the computer. And I'm the CTO. Started this company many years ago now. Seems message, but does not show them fixing it. Oh, dang. Let's see. Ah, darn. Okay. So yeah, this is what I do. But I do stream because I'm using stream to chat with you guys and learn what's going on in the world. Sometimes you guys will say, hey, did you hear about the new Fable or the new, whatever? And I'm like, oh, wait, I don't know. Tell me about it. And then I learn about it. There we go. What, George? You don't have to do that again. What are you doing? George, my goodness. You gave everybody. Everybody's got a membership now. What? George, you didn't have to do that. Look at that, you guys. That's crazy. Thank you, George. Very much. Thank you so much. My gratitudes. 1 hour means 11 p.m. Yeah, it's going to be a little bit late. Yeah, don't worry. We'll make it, though. We'll make it. Let's wake up some sleepy subscribers. Hey, George. Very nice. Thank you so much. I appreciate you. Software engineering, or CE, please tell me. Should I study? Electrical engineering could be a lot of fun because there's a lot of hands-on. Probably a safe job for the next few decades. George, I can't believe it. You woke up everyone. Look at that. Everyone's got a membership now. Everyone except for Snot. Snot didn't get one. Hey, Sergio, thank you for the GGs. Appreciate you. Have you ever met Elon Musk? I've not, but I've lived really close. I lived 2 blocks from Twitter. That's where I used to live. I used to live in San Francisco, and I lived 2 blocks away from Twitter, which was as close as I've ever gotten. Thank you for saying, hey, absolutely, you're welcome. Thank you. Thank you again. My goodness, you've got the memberships just popping up. Good afternoon. Hey, how's it going there, Didam? Good to see you. Welcome on in. Happy Saturday. Dang, that's crazy, you guys. Thank you. Sergio, also thank you for the GGs. Appreciate you. Okay, where are we at? You distracted me, you guys. You distracted me real good. We are building a Retrieval Augmented Generation. Quick fix. Are you a member? I don't know. You have to chat. If you chat, I'll be able to, I could also look it up, but I could just wait and see. All right, user ID. Yes. Path ID. Get user path, shared state. Yes, I like it. Okay, so now we've got all the information we need here. We've got our rag state here. So let's do this. We're gonna have a struct rag state, and we need to do a lot of things in here, right? We need our Turbovec. We need our SQLite. We need our embedding. Maybe, yeah, probably. Well, do we though? Yes, because we want to load it once. So we need our embedding once. Yeah. Thank you again, George. I appreciate you. Why are you doing this stream? Wada. To learn, right? We're learning. So we're building a Retrieval Augmented Generation now. I'm keeping up with all the information. It's really helpful and beneficial to me. Do you still have a free giveaways? I will in 4 days. Let me check. see, membership gifting. Yeah, I will in 4 days. Yeah, so in 4 days. Quick fix, I will in 4 days. And it's random. It's completely random. I have no say in the matter. So if you get one, that is a lucky adventure. If you don't mind, can you give advice on how to get job with specifically in finance data analytics? Currently working on your GitHub repos. All right, so here's the deal. This is very, very important. You got to listen to this. If you're looking to get a job, very often there is a very common strategy that has been used for decades, and it's still the same strategy today. You need to get an entry-level position, not the position that you want. You can't. There's too much competition. A very good trick is a foot-in-the-door entry-level position that is not the specific role that you are currently looking to achieve. However, it might have a path to the job that you want, right? So if you want a job as a financial data analyst, you might get something more like a customer support role at the company that does those kinds of roles, right? So if you have a data analyst firm and you want to be a customer support representative at that company, that will give you the foot in the door. And your qualifications are going to be really high compared to everyone else applying to that role. So you apply to a role that you're overqualified for, and then eventually you have a chance to step into the role that you're really looking for. That's the trick. It is. It's the same as it's always been. It's not any different. It's something I had to do. It's something that everyone else on the planet has to do. Or if you get lucky and you get like a really good entry-level position that is the exact job that you want, very few people get that. So there you go. Beast Hunter, good to see you. Bon Zoopy, welcome on in. Mick G, Lucky Luke, welcome on in as well, you guys. Good to have you here. Are you the backbone of Swiggy? Oh, yeah. You guys, you noticed. Yeah. So we got some Swiggy in here. We do all of the delivery notifications, all the chat communication that goes in between the driver, passenger, the restaurants, anything that the coordinates. When you see the driver approaching you on the map on your phone, you see the driver coming on your phone. That is us as well. Old school trick. You got it, Surf Tube. Old school trick, and it works. You didn't know that you're also the founder of Pubnum? Yeah. Yep. Started it a long time ago. It works. Really? Nice. Exclamation point. That's great to hear. All right. We have the window open around here somewhere? All right. I don't see it. Send it on Discord. That's so cool. I know, right? I think it's pretty cool. I think it's pretty cool too. Your name's Andre. Andre, I'll try to remember. McG Lucky Luke equals Andre. It might take me a few times to remember. So, McG Lucky Luke equals Andre. Okay. There we go. Then you should write founder and CTO of Pubnum on LinkedIn. Oh, well, I did. I suppose we could change that really quick. You guys think you think we should? Should we change that? I mean, I think we could. Triple equals. All right. Yeah, we go. Triple equals at Mick G Lucky Luke. Triple equals Andre. All right. There we go. So you're the guy on the map delivering. Well, yeah, we are. Exactly. Beast Hunter, you got it. You figured it out. Well, here's the deal. So I'm not the only founder. So Todd Green is my co-founder. So, right? See here, Todd Green. So we've got, right? Todd Green is the CEO. So we co-founded the company. So I could say, here, let me do real quick. So we'll edit. And then we'll say co-founder CTO. There we go. Founder. There you go. All right. You asked for it. You asked. All right. Here we go. Boom. Updated. Did it work? All right. Updated. Boom. Right there. There you go. Terry A. Davis. Oh, yeah. That's right. Terry A. Davis. I know, right? Temple OS. I remembered now. It only takes me a few times to remember. Temple OS. Yes, sir. Do it. We did it. There you go. Steven, you're not recognizing my message. Oh, Venom. What'd you say? I don't see your message. RAG is awesome. Distillation, good architecture. Yeah. RAG is awesome. Distillation is different. Distillation is the practice of taking another model, getting the outputs from that model, and then training a smaller model. That's distillation. Check it, link share. Okay. Link share. Here we go. All right, there we go. Test. Is it working? All right. All right, let's see here. Let's do test. Hey, look at that. Test over here. It only works on Twitch for now, though. Okay. Very nice. Okay. Quick fix. Very nice. You did it. All right. Yes, sir. And by the way, what is Series E? So when you're doing raising venture capital, right? Venture capital, VC, that is typically prefixed with a letter based on the current round, right? So you've got like angel rounds, seed rounds, and you've got venture rounds. Venture rounds usually start with letters. So you got A, B, C, D, E, F, G, H, I, J, K, L, M, just all the way up. And it keeps going forever. And those are all private equity rounds. So they buy stock in the company that you can't buy because it's not a public company yet. So this acquisition of stock in the company at a private price. Does that make sense? I think it does. Can anyone in mobile number have international connection? I don't know. I think so. I'm pretty sure. Are you building your own LangChain kind of thing? Yes, we are. We are building a RAG, a Retrieval Augmented Generation engine written in Rust. We're going to use Tokyo, Axum, embedding, Vector, Turbovec, SQLite for the database and metadata in the original doc store, LLM for summary, and then maybe a user interface. Maybe we'll do iced. So that'll be like the icing on the cake, if you will. Is it endless? What is endless? Oh yeah, it keeps going forever. It will. And at some point though, you typically want to give, open up some shares to the public. So it's your initial public offering. So you can open up some shares to be sold. It's also for a way to raise money. You can do that as well, right? All right. So Venom D, your chat message. Let me see here. Let me double check. All right. You said, Steven, you're not recognizing my message. Brother, can we exchange our contact number? Send me a message on Discord. Send me a DM on Discord. Yeah, a DM on Discord will be the answer. All right, real quick there. Okay. Hey, SurfTube, thank you for saying hi again. Why not use Postgres? Because I want to make it really, really fast. Postgres is another server. It's separate. It's independent, right? It's a really good engine. SQLite is going to make it even faster. It's going to take that latency from milliseconds into microseconds. I want this to be the fastest possible Retrieval Augmented Generation API server you could ever possibly have. All right. Try to watch. Oh yeah, I see that. Pin. Well, so here's the deal. I think we get penalized if we try to take people off platform. Quick fix. I think we get penalized if we take people off platform. International connections. I think so. Wow, that's awesome. Isn't it? It's pretty cool. I'm really excited about it. Oh, sorry. Yeah, I think we got to be careful with that. I'm still learning, right? So you guys, I'm in the YouTube community partner program. I don't know if you can see it's right here. I'm not going to click into it because I don't want it. I'm supposed to keep that, private. But I'm there, and we meet like a couple times a month with a community partner manager. Someone has rewritten SQLite and Rust. They did. Yeah, they did. Bonzupi. Should we use that? Should we use that instead? Do you think that would be better? That was Terso. Terso did that. Yes. Terso rewrote SQLite in Rust. They did. Can we use database as text or Excel file? Yes, you can. For a beginner project. Yes, you can. Yes, you can. Thank you so much for bringing that up. There was a time in my past when I was working with a team, and they didn't understand what a database was. They really didn't. They didn't even know what it was. They're like, oh, you can't have a database unless it's MySQL. I'm like, no, a database counts as anything. A database can be anything. It could be an XML file. It could be a text file. It could be, a series of files on disk. It doesn't matter. A database is a file on your operating system already. What a database also usually includes is some sort of indexing. And the indexing can occur in real time. It can occur post or ahead of time. And it doesn't matter. It doesn't matter. They're like, oh, an XML file can't be a database. Yes, it can. You can index it. You can load it into memory. It counts as a database. It's a data storage format. And it can be a database. It can be. Sorry, I had a rant on that because in my past, I had situations where they were wrong, but they were very confidently wrong. They're like, it's not a database. Yes, it is. It is. It counts. It's actually good. Bonzupi. Someone rewritten it. Yeah, I'm not sure. I heard it could actually be good. So I think we might want to try that. So let's take a look. All right. Terso, Rust, SQLite, rewrite. Let's try that. How's it going there? Hange, thank you for subscribing. Appreciate it. Good to have you here. Happy Saturday. You joined the right channel for software engineering. Is it called Limbo? All right. I like Limbo. I played that game. Complete rewrite of SQLite and Rust. Is it ready? 2024. Okay. So I think Limbo would be the answer, right? So is there a GitHub for it? I remember libSQLite, SQL, then Terso. Where's Limbo at? Limbo project in the Terso database. Now available at. Okay. So do we see Limbo in here? We do. Okay. Where is it at? How do we do it? How do we do it? All right. Crates.io. We'll go Limbo. Is this it? Limbo Rust API. Is this it? It is. How do we use it? Let's find out. It says not helpful information. Okay. We need to be able to know how to use it. So let's take a look here. Okay. Let's go back real quick. Is there anything in here? No. Okay. Limbo. I don't know how to use it. They're not giving me any information. Let's see. Oh, hey, Kyle. Good to see you. Welcome on in. Did I train it overnight? I didn't. I did not leave it running overnight. I should have. Right now, we're moving on, though, to a new project, the Retrieval Augmented Generation project. We're starting from scratch. So we got all of our files here. We're good to go. And now we need to write. We started writing the code, all from empty, all from scratch. Hey, Silvanki. Good to see you. Wait. Silvankani, good to see you. Welcome on and happy Saturday. I know I keep trying to relearn how to say your name, but you know what? We're gonna make our way, you guys. All right. Okay. Don't look behind you. All right. I know, right? I can see in my camera. It looks fine. Opal mushroom. See, front end. I'm perfect Python and not another language. Should I use Streamlit? Or any other package? Or should I learn a framework, which is better? What is Streamlit? Google Streamlit? What is that? A fast way to build and share data apps. Open source Python framework. Oh, I've never used it. I have no idea. It depends on what your objective is. And your washing machine too. Oh, hey, yeah, the washing machine. I've been using that today. Get some laundry done. All right, you guys. Let's see. I need to continue on with coding here. What about Postgres? Right, Kuno, I know, right? It keeps asking. We want to use something that's going to be really fast, so we're going to use SQLite. I think that's going to be the answer because it's really simple and straightforward to use. Hey, Nitwa, good to see you. Happy Saturday. Welcome on in. Good to have you here. Don't expect to love your stream so much, but seeing you makes my day better. Oh, that's really nice to say. Thank you. Thank you for being here. I appreciate you. OND Gaming. OAP Indie Gaming. Thank you so much. It's good to have you here too. Let's see, catching up on the chats real quick. Streamlit is mostly used by data science guys. Got it, yeah. I've only ever used scikit-learn. I've used PyTorch. I've used Keras. I've used TensorFlow. I've used Burn and didn't like it. I didn't like Burn. I would like to try Candle. I'd like to try Candle. I think that would be good. You second that one, Mickey Juck Lucky. Oh, wait. Andre. Yes, you second that one, Andre. All right, I'm remembering now. If you chat, I remember Streamlit is a Python-based UI, usually for AI, MVP, but I recommend Gradio instead. Okay, Gradio is the recommendation. All right, good to know. Good to know. Science guy teaches you Streamlit. Hey, very nice. Very nice. All right, let's get back into coding here, you guys. All right, so I want to... So we've got our SQLite. I would use Limbo. I want to use Limbo. They're not making it easy. They're not. So there's no information on it. There's just none. There's no information. All right. Terso, Rust, Limbo. Introduction. Is there more? See, it's just the intro here. Yep. Yeah, it's not giving me any information. It's not telling me how to use it. Here we go. Drizzle, Limbo, WASM. Do we want to do that though? Is that what we want to drizzle ORM? We don't want to do, this is JavaScript though. So I need to see the Rust crate. Yeah, all right. It looks like they don't want me to use it. I tried really hard. I tried really hard, you guys. Venom. All right. Okay. Let's see here. Catch on, my guys. Mostly data science, probably. Yeah. Streamlit. Prefer learning JavaScript for web dev. Yeah, there you go. Not with Rust. Yeah, I think so. Right. Right. Wait. Andre. Wait. Hold on. Andre. Yes. 1 second. 1 second. Terso. Let's see. Tests. Mick G. Lucky Luke is Andre, right? And then Thank You Bro is literally a project for you. All right. Rust or Python? Python first, and then Rust is my answer. All right, let's get back into our code here. All right, let's make this work. All right, our rag state. Yes, we don't need one right now. I think we'll say let rag state. And do we need to do a box, right, around this? Rag state. Do we need a new? Hold on. It's been a while since I've done this. All right, here we go. App state, arc clone, shared state, and that's going to be here. Okay, so we need an arc, std sync arc. Okay. Let's see. Use std sync arc, automatic reference count. Okay. And that's fine because we're only going to do it once. So we've got our standard arc here, looking good. Okay. Use standard sync arc, right? Did I type this right? Yeah, that looks good. Right there. Okay. Save that. And then we need to say let state equals, and our state is going to be an arc new. We're going to say rag state, like that, right? Can we just do it that way? We need the brackets. Yep. Save. No errors. Looking good. This isn't going to be an arc rag state. Like that, right? Help if this is intentional, prefix with underscore. Yeah, it is unintentional. Okay. There we go. Looking good. Looking good. Ask ChatGPT if you have any doubt. Yeah, that's the way to do it. That's the new modern way. Learn today about the history of why lists arrays start from index 0 and not y1. History of CS is really interesting. What is the reason? Enlighten us. Enlighten us. Hey, how's it going there, Neon Java? Welcome on in. Happy Saturday. Good to have you here. We are currently building a Retrieval Augmented Generation in Rust, and we're going to build it to make it amazing. This is going to be one of the best RAG engines, hands down. We're going to use all the search capabilities. We're going to do multi-ranking. It's going to be really, really fast, and it will support terabytes of data. It'll be huge. It'll be amazing. So good, so good. Okay. So we've got our state, our app. All right, looking good. Now what I need to do is figure out how to deal with this here. All right, route. Yeah, it looks good. User, and then we've got our posts. How do we want to do this? Let shared state arc clone. For every request, we create a clone of the shared state. Every single request. Is that what we want to do? That's what it's recommending. User path string, state. Okay. Got it. Create user, get user. So we want to mimic this or this. Well, the post really is what we want to do, is the post, because I want the body, right? Create user, JSON payload. Create user payload. Where is this? Do we have that anywhere? Oh, it's a struct right here. Okay. So we can deserialize that. All right. So this will be a prompt. So we'll have a struct prompt. Struct prompt. Prompt. Yep. Okay. And this will be text and string. Okay. Expected. Fine. Let's do a regular string then. Not a problem. Not a problem. Will SQLite always stay fast, or will the data... It stays fast as long as you index it, right? As long as you have an index. So we're going to use BM25 for word rankings and full text search. We will use it for slicing and metadata. And we will create indices on the right columns, and it will remain fast. What about an old project creating GPT from scratch? Oh, we did that. We did it. It worked. We achieved it. We made it work. But it wasn't full ChatGPT, right? It was really a Stephen GPT. We wanted to train it to say Stephen words. And what I need to do is, if I wanted to continue further, I would train it longer. So that way it knows how to speak Stephen better. It spoke Stephen pretty good. It did pretty good. Wow, that's really awesome. Oh, it's so good. It's so good. Okay, so we've got our post. This is our root. And where are we at post? Okay, so we have to do some extra stuff here with this. So let me see here. Let's share. We don't need the ID. We don't need that. Let shared state. Okay, so let's do this. Let's do this part right here. So we're gonna change it up. Post. Well, you know what we could do? We could do this. I like this idea better. There we go. And then we're gonna do a... What is this? What do we have in here? Do we have anything in there? Interesting. Let shared state. Okay. So we don't need that. We just need this. Post route. Yes, looks good to me. What? Oh, okay, I see. Yes, all right, got it. All right. Wait. Oh, bro. So I missed the end of yesterday's stream. I will watch it after stream. All right, yeah, we did it. We got it working. It took a while. It did. And at the very end, we got it working. We did. It was great. It was amazing. I had a lot of fun with that. Okay. So we're gonna say here. So let state. We can. Is an ampersand state equals arc clone our state. Let's put this over here. We don't need an underscore anymore. State arc clone state, and it needs to be the reference of it. There we go. And then we've got our state now. Good. All right. And we're going to do a move path. Although, where's... Do we find path anywhere? No, body. Okay. Body. Although we don't know what body is. Body's never been defined. Create user body. All right. Where is body at? Is this going to work? I don't see this working very well. It would also be nice if I could just say, call this function over here. Just call it over here. Okay. You dropped suggestion in Discord to reduce the bot message spam. Check it out later. All right. Neon Java, thank you. Appreciate it. Indexing starts at 0 because early computer scientists designed programming languages to match the way computers access memory. Starting at 0, 1970s, the C programming language treated it as an array as a pointer to the first memory address. So you start at 0. Otherwise, if you don't start at 0, then you're throwing data away, right? You're throwing data away. I mean, conceptually, you're throwing it away. So the first element was located at position 0, away from the start. Nice. This made memory calculations simpler and more efficient. Yeah, that's right. You wouldn't need to do any extra operations to say if you want to start at 1 base index, right? So your base would be 1. If your base was 1, then you wouldn't have to subtract that to get the address. You could just straight up call 0 and that would be the address. I like that. More efficient. C became one of the most influential programming languages. Many modern languages such as Python, Java, and C++ are adopting the same conventions. Yeah, they do. You got it. How long did the final training take? We spent 2 hours on the training. If we wanted to, we should keep training it for like a couple of days, and then it would be perfect, Steven. it would be near perfect Steven. So I could do that. We could. Bunzupi, we could do that if we wanted to. We did pretty good though. See, I told you body doesn't exist. It's going to be a problem. Create user. Oh, we are going to call this root. Root, create user, body, and the state. Right? Shared state. There we go. Root. See, unexpected argument. All right. And then what do we have down here? Okay, create user. We need a payload and state. Okay. So I can just type this easily. Root, we're going to say JSON body. I'm just going to say JSON body. And then it's going to be a JSON create, and then we got a struct, which is going to be prompt. Right? JSON prompt. And then we need state, arc, and this are our state. Rag state. Rag state. There we go. Like that. We also need to import JSON here. So we need Serde. Oh, Axum JSON. Okay, we could do that. Axum JSON. Extracting. So we need extra stuff here. Let's grab extract. Redo. Extract. Go. Excellent. Okay. So does everyone do this with RAG for like AI big tech? Yeah, this is going to be, we're going to build a very, very good, large, capable, super fast, amazing RAG engine. We're going to build it so that way it's going to be the best in class. Can it get better than what we're going to build? Yes. Can it get much better? No. We're going to build it to where it's like basically 99th percentile. You're going to get really good. Amazing. And in enterprises for RAG, they typically would use something that's less performant than this because they're just trying to throw it together. So they would use something like Python and LangChain, LangGraph, which are performant. They're just not going to be this level. It's not going to be at this level. At last, this is just basically a bunch of wires and electricity. Yeah, it is. You got it. It is a bunch of wires and electricity. You got it. BG music is nice. Where did you get this? Help. Yeah. I love this song. This is one of my favorite songs. It's called Splashing Around. Splashing Around. I love it. It's great. It's like upbeat. It's happy. It's emotional invoking. Wait. We're going to do that song again. Sorry. That song started over. We're doing it again. You have no choice in the matter. Entirely convinced that the overhead of embedding model for RAG is worth it. Bonzubi, right. So you don't even need the vector part of it. You could just do full text search, right? BM25, easy, boom, done, easy, right? We're going to do the vector side of things because it can help improve when fetching segments of data. And so I think we're doing a hybrid, right? So we'll do a vector full text search hybrid, right? Bonzupi, you know it. Topological hypergraph, similar to semantic search capabilities, but less overhead. Oh, really? Okay. Then of course there's grep. Oh yeah, just do regular grep. You can do that too. Is there any mods of Steven's DSs? What's that? What's DSs? Grateful use one specific person. Fraud promotion. What? AW9Q? What are you saying over there? Discord. Oh, Discord, yeah. Oh, mods. Yes, there are Discord mods. Would be grateful. Yes, we've got some Discord mods here, you guys. They're here right now. You got it. They're here right now. Okay, so where are we at here? Extensions and path. Did we do path? Did we get that? Are we using path anywhere? Path. We are not using path right now. We're doing a post, so we can get rid of path. So we're not using it. Are we using extensions though? Maybe. How about we comment this out? Good. Body, help. If this is intentional prefix, okay. So we have not used that. So let's go here. Let's say print ln exclamation point the debug value of body. Let's try that. Body prompt cannot be formatted because it does not have a debug. Okay, fine. What if we did that? Cannot be formatted because it's a default formatter. Well, I want to use it for something. How about we do this? Debug, DBG. How about that? See if that works now, huh? Explanation point. The debug trait is not implemented for prompt. Okay, fine. Sure, okay. We're gonna just do an underscore then, There we go. Underscore. Let's get rid of the warnings. Text field never read from. Text field, text. Where's that? Oh, right. Underscore. Everything gets an underscore. Everything gets an underscore. All right, unused closure that must be used. Did we not use it? It looks used to me. Oh, we have to return it. There we go. Yeah, we're returning it. Return, right here. Do it, return. Return it. Okay. Return move body, the expected closure. Yeah. So we got a problem there. Okay. Pep stepper. Pep stepper, yeah. All right. 1 second real quick. Let's see. Android. Okay. Got the Discords going. This is going to be awesome. I'm excited about it, you guys. I'm excited, yeah. Let's see here. All right. Kunal, yep, sleeping. I know, right? It's going to happen pretty soon. All right, so we got about 23 minutes left. We got about 23 minutes left of stream. We got started. I think we got a pretty good start here. So we've defined our total objective, completely designed here for the most part. So you got the answer. You've got your databases. You've got your original docs that we've chunked into data. We're vectorizing. And then we've got our Axum Tokyo, Vector Store, Turbovec, SQLite database, and our LLM summarizer. Okay. So what is my challenge here? Would be nice. Can we do this? Yes, okay. All right. Unsatisfied trait bound. Did we do it wrong? I told you it looked weird. I already told you it looked weird. Required by this bound in post. Handler. H. Top level handler post required by. All right. So there might be a different way that we could do this. We're not going to use the AIs for help right now. We're gonna try to get this to work ourselves. Let's just comment stuff out until it starts working. How about that? There we go. Commenting everything out. And then we'll just do this. Right? All right. Comment that out. Comment that. Okay. Green? No. State. Yep. All right. So we're not using it right now. Okay. Looks good. Perfect. Okay. Underscore. We are using it's right. Oh, I see. There we go. Okay. Struct prompt unused code. All right. Yes, you're right. We are not using it. It's not happening. Let's see here. Let me quit this. All right. So bacon. Getting rid of warnings. What I do after stream, Kunal? I don't know. What do you want to do? Enjoyed your stream today. Hey, yeah, we're good. We've got time left. We're not done yet. We've got about 21 minutes. We got plenty of time. Crypto casino scam promotion across some channels. Gotta be careful. So, if you want, what I really want to do is more AI. That's what I want to do. I want to do more AI. However, you guys asked for it. You said, hey, we need to do a Retrieval Augmented Generation stream. And I'm going to give you a really good one. That's my plan. I'm going to give you a really good one. This stream, we're going to have all the good stuff. Everything that's good. Nothing left for interpretation. We're going to do some really powerful things here. So I'm going to get our Axum server ready to go. We're going to have a good Axum server. Can we get rid of that? See if that looks good. All right, so I'm going to keep that clean and simple. We already know what it is. It's an arc rag state. Looks good. So we need to do here, we need to add a few things. We're going to add our embedding. We need our Turbovec. We need our SQLite handle. Turbovec handler. And this will probably be an impl mod that we do ourselves, right? We could also do that here, and we could call this like a database. And then we also need our vector. This is our vector store. So we got to do those things, Eric. And then was there anything else that we needed? If you guys remember, LLM. I guess we could have maybe the LLM handler. Could do that as well. Good and better vector store database element handler. Good. Okay. So we've got our list of things that we need to add into the state. This will be added into our state object here. Let's see. Spamming constantly, time that after a week. Ooh, got it. That's a long timeout. One more question. All right, Kunal. Before I sleep, Primogen said to become a coder like me, code 8 hours a day for the next 2 to 3 years, and then to a job and do self-study for the next 4 to 5 years. What do you think about that? I mean, that's what I did too. I coded hardcore all day, every day. This was when I was, young in before adulthood, right? Before adulthood, I would code. And then I went into business immediately at 17. At 17, even before that, I was basically doing business. And so that's when I really got into coding, was when I started really focusing on business and software. And so I had an objective, I had a goal, I had an aspirations, and I wanted to do more, and I was getting results, and I wanted to get more results, and I wanted to keep repeating that. What didn't work, what did work, and I wanted to just keep going. So for me, it was a little bit different. We were on a similar journey though. Very similar journey. No, I was just asking what you do after. Oh, what I do? I'm going to do chores. I have to take care of things. I need to do food prep, right? For the week, because during the week, I spend basically all day working. I work all day. And so if I do food prep, that means I don't have to do as much not working during the weekday. And then I do chores on the weekend. I used to have helpers. When I was living in San Francisco, I had helpers do all the chores for me. Then when I moved to Seattle, I just haven't gotten helpers, and I kind of like it. I kind of like doing everything myself. It's a lot of fun. It feels good, is what I mean. It feels good. Steven has 26 hours a day. There you go, right? An extra few hours. Baking broccoli. Yep. I am going to be baking broccoli. I will. After stream ends, I'm going to go to the oven and we're going to bake some broccoli. Yeah. I'm serious. Yeah. Breakfast. Damn. Yep. There you go. You got it. What is your reference to building RAG on Rust? Are you referring to any papers? We are not. We designed it ourselves. So this is our design right here. We're going to be using Axum Tokyo for the web server. We're going to use an embedding vector. I don't know which embedding we're going to use. We'll use something that's pretty good. Not anything that's too heavyweight. Something that's pretty good. We'll use SQLite for the data store and Turbovec for the vector store. SQLite already has a vector store and a vector index built in. Turbovec is just a lot faster. Doing chores is also a big task. You got it. Made snot. Yeah, you got it. Yep. You know it. All right. Did we get everything here? All right. So is it going to the next song? Let me see here. Let me get the next song going, guys. Where are we at? I'm over here. It's loading. Okay. Song. Perfect. All right. Understood? Yeah, there we go. Oh, whoa. Oh, look at this. Hey, look at that. Oh, it's a laser pointer. Hey, I didn't mean to do that. I didn't know I could do this. Hey, this thing right here. Oh, what about this over here? Check that out. Hey, I didn't know that was a neat feature. That was an accident. Yeah, so we're going to be doing our web server, which is going to be Tokyo Axum right there, right? Our vector store, Turbovec. It's a new Rust-based vectorizer that allows you to index vectors in its fast retrieval. Then we need to define what our embedding model is going to be, right? And these are going to be the words that convert words into numbers that we're going to store into our vector store, right? And then we're also going to store the original document. So the original documents will be coming down over here, like that direction, right? So we got a lot of plans. This is what we're doing right now. You like the TL draw? Oh, I haven't. Yeah, I've tried TL draw a few times. You would love more emphasis on a more clear beginning, middle, and end when it comes to projects. Review what was completed, learned, and how it ties in. Yeah, okay. So right now we're getting started on just the web server part of it. So we're starting right here. We started with an empty file, and this is going to be, I like to start here because this is going to be the inputs and outputs, right? So one of the inputs is going to be add a doc, right? We're going to add a doc to the vector and the database. So we'll add a document, right? And then we want to prompt it. And so this will also be the prompt where we do the prompt side of things. So we want a root index to allow us to prompt based on post data. So that's what we're going to do. That's what we're writing right now. We're writing the prompt side of things, and we'll also add a doc. So see, to do add a add doc. We'll have like an add doc command. So maybe it's like a /add, for example. Something simple like that. And it'll be another post. We'll do another post. In fact, we could do that right now. We could do it right now. Add. So this will be our add document to the RAG DBs. Here we go. Let's see. We'll prompt. This is the prompt. Prompt for, let's see, user prompt. Query. Yeah, user prompt. I think that's fine. Let's user prompt here. And this is where we add our docs. Dot route. There we go. Clean that up there. There you go. Why not write a vector database from scratch on Rust? Ooh, that's another idea. That's something completely different, right? So we're doing a RAG now, which will be using a vector database. We could write our own. There you go. There you go. Write our own. I'm going to add that to our Discord. Let's do it. We'll write our own vector database. I wanted to do that. I really did. I wanted to do that. I wanted to do that for a long time. Test. Still works? Still works? Nice. I wanted to do that. Okay, so let's add that to our ideas. Stream ideas. Here we go. All right. Wait, how about this? Vector DB from scratch, right? So write our very own, did I type that right? That's scratch without a T. There we go. Write our very own vector database from scratch in Rust. Yep, we could do it. Rust. Boom, post. All right. Wait, I typed that wrong. Can I edit that? Is there a way to edit this? Because I didn't type, scratch. That's not right. Is there an edit here? Edit post, here we go. Scratch. Excellent. Nice. Okay. Saved, done. Vector DB from scratch. There you go. Hey, I like the idea. Thank you so much. Hey, Neva, welcome on in. Happy Saturday. Good to see you. I'm doing very good. Thank you. Didn't you already train an embedding model a couple months ago? We did. Yeah, we did. It was trained on a very small amount of data. It was only trained on Python code. So if we want, we could potentially use that model. We could, right? Well, it wouldn't be general purpose though. And I want this to be a really good general purpose RAG engine. So this is what I want, a really good general purpose. And it's really gonna make it work. Oh, we need to do testing as well. We should do tests. Add tests. So we've got a lot of work ahead of us. A lot of work. A vector DB algo are ridiculously annoying and complex. Are they really? Are they really? I mean, you just need to find, you need to create an index, right? So you can do a fast retrieval. So really fast retrieval. And I believe we could probably do that with a bunch of hash bucketing, right? Maybe a hash bucket. I think that could be work. So you get your vectors and you create a hash bucket tier of some sort, right? Maybe a graph, right? A bucket graph. And then you can get the exact documents that you're looking for. Yeah, whatever slices that you're looking for. I think that should work. I mean, we'll study up on it and then we'll build it ourselves. So that'll be a good plan. I like that idea. That one sounds like a lot of fun. I like that. Sounds like a lot of fun. Thank you again for the idea. Or just the other linear stuff. I assume you want to write an O log in like with R trees. Oh, with R trees. I don't know. We'll have to find out. We'll do the research. Arctic embedding, nomic, embed text and Granite embedding are probably the best general purpose in models. All right, let's write that down. Let's write that down. All right, so Bonzupi said to do Arctic or Nomic embedding models. You said Granite, Nomic, Granite. Nomic here. I don't know. I've not heard of these, so we will look them up. We'll look them up when we're ready. We'll add these in. Thank you, Bonzupi, right there. Hash can't work because you need KNN search, similarity, grouping, and clustering. Got it. Well, okay. So we'll look into it. We'll look into it. I'm pretty sure we'll come up with some really good options. We'll see what it looks like. We'll make it work. We'll make it work. However we do it. You have to do space-based, data-based. Got it. Okay. See, general. Wait, quick fix. You said something in general. General. Oh, hey, Neon Java. Oh, hey. All right, I'll have to catch your message here in a sec. Let me see. Wave. All right. Configure bot image 12 hours. Okay. Watching Steven's project. Yay! Very nice. Quick fix. Yeah. All right. Whoa! There's a picture on. Oh, that. Hey, check it out. Test right there. It's working. It's working right there. That's awesome. Check that. Quick fix. Good job. Good job, quick fix. Fire. All right. Here we go. You can also do the timeout, the user, and delete last 1 hour chat. We could. Why would we want to? Also, for small enough, linear is fine. Linear would be fine, yeah, for small enough, for sure. If you just be approximate KNN, you can do simpler stuff. Okay. All right. Good to hear, Neva. Excellent. I like it. Arctic embed text is the largest, around 600 million parameters. Whoa, we want to go a little bit smaller than that. Like embedding Gemma is 300, so I would like something smaller than embedding Gemma. So you're saying Nomic? All right, so we'll probably do Nomic right here. Nomic. This is the one right here. Let's do some Nomic. The target choice. Here we go. All right. Bonzupi says Nomic. All right. I would like to at least get the web server running really quick. And I think we could probably do that. We only got 7 minutes left, you guys. So can we get that working? Where are we at? Yeah. All right. I would very much like to see this working here. Let me see. User response. Nope. I don't want that. This is the design I like. Although I would be nice if we could do it differently. So we've got our shared state. Body, post body. All right. So this part works. Although this part has a problem. This part isn't working right here when we do this. So it doesn't like that. Oh, root. Did we not have root defined? Oh, we didn't define it. Here we go. Okay. So root's defined. JSON. Oh, did we not import JSON? There we go. JSON. There we go. Okay. Post required by bound introduced by this call. Is this correct? Hold on. So are we doing this correctly here? So post looks good to me. Yep. Looks good. Looks good. Oh, well, here, hold on a second. Okay. So route. Okay. That looks good to me. Okay, right here. All right. You'll be building a server. Yes, server. Yep. I need to learn Rust. Hey, yeah, exactly. Andre, yes, exactly. Granite is 30 million for their English only model. Oh, Granite. So maybe that's a really good like starter model, right? Granite for really small. Granite 30M. I like that. Nomic is like 200, 250M. Okay. Good to know. I would like to solve this down here. So what do we got here? Post required by bound introduced by this call. This tail expression of type : closure. Unsatisfied trait bound. Handler is not implemented for closure. Is required by this trait bound. So, what do you want me to do about that? What do you want me to do? Handler. How do we do this? State can also be passed directly into the handler using the closure captures. Is there other ways to do state? I would much prefer... Oh, I see. Okay. All right. Let me think about this. So this might be a better way to do it. So instead, shared state, layer.extension shared state. Okay. Yes. Let's go this route instead. Let's try this. Delete, delete. Let's see. We'll do a route, post, root. Okay. Post root. And then we do a layer extension at the bottom. Layer. Extension, shared extension. Do we already have this defined? We do. Okay, here we go. Extract extension. All right. Layer extension. And this will be shared state. And our shared state, it'll just be state. Right? So we got our state, shared state. Yep. We got our handler. Layer extension, shared state. Looks good to me. Okay. And then we need to do some extra stuff here. Unclosed delimiter. Did we not close it? Route. Oh, we didn't. Okay. There we go. Unsatisfied trait bound. Root. Did we not do it right? Oh, right. We need this here. All right. I'm going to grab this. Let's go over here. Prompt state. Go. Okay. Here we go, you guys. No, undo that. Yes. Okay, perfect. Okay. So we got our extensions. We got our JSON. And then we don't need this extra state over here. I don't believe, right? Okay. Prompt. Question mark. Go. Okay. This is going to be arc extension arc rag state. We've got our prompt. There we go. Save. Okay. Expected one of. How about we just close that out for now? There it goes. All right, we're doing it. Hey, check it out. Green. Finally. It only took a little bit, just a smidgen. So we made our way. Okay. So we got our state here. We got our route. We could actually probably run this. And it will, let's see here. How do we, is there any extra code that we need here in our main? Okay. We got to do this part right here. So let me do this here. Thank you guys for the hundreds. Appreciate it. Neva, what's the project today? We are doing the RAG. So let me grab this here, the README. This is RAG in Rust, Retrieval Augmented Generation. It's actually pretty straightforward and simple. If you're thinking about all of the different things that we've done on this channel so far, it does require, it's a higher level project. So it takes a lot of components and brings them in. A lot of components. You've been building the server now? Yep, that's exactly it. You got it. Why aluminum? What's aluminum? Oh, Axum. Those are very different words. I love Axum. Axum is great. Axum is very simple. It's straightforward. It's clean. Look at how easy it is to create handlers. It's Pythonic, right? It's Pythonic. Zoom in on that right there. See how clean this is? It's super clean. That's what a framework should do. A framework should make it really easy. Autocorrect thought Axum aluminum. Yeah, I got it. Yeah, there you go. So, yep. That's why Axum. Because easy, fast, and there was another web server that came before Axum. It's called Actix. Actix had a falling out with all of the engineers in their team, and it didn't go down the path of simplicity or performance, and it had a bunch of problems. Sure, they've made adjustments, and Actix has been around longer. Axum is an evolution. It's the next level over Actix. They rewrote it intentionally for higher performance and easier use. That's why. Why do the web servers at all? Because we want some good input output. We need to make this usable, right? A web server is going to make otherwise a RAG isn't a real system, because you need to be able to consume a prompt from a user, right? You have a prompt from a user, like a user is going to give a prompt, right? They're like, hey, I need a question answered. And then the RAG is going to pull in extra information related to the prompt. And you're going to feed all of that to a large language model. So that way the large language model can make a better response, right? Got it? Not a RAG app, but a RAG API. Hey, yeah. All right. Let's update this. Here we go. Let's update this to say RAG API. RAG API and Rust. There we go. Clarification. There we go. Very nice. Thank you. Thank you, Neva. Steven, you like your channel? Oh, because you are building stuff for self-improvement and mostly fun. Yeah, there we go. Yeah, that's it. Dadam, you got it. YouTube has been a race to get rich fast lately. Yeah, yeah, it has been. Yeah, you're right. And we're actually just having fun here. So what we're doing, we're learning, we're building, and we're chatting, and we're just getting up to speed with everything. You got it. That's us. You know it. You got it. How's it going there, Mr. Sova? Good to see ya. Hey, any tips releasing project proofs and finding a name for it? Any tips about releasing a project? Finding a name? Well, you can brainstorm, right? Thank you for the hearts, guys. Appreciate it. You can brainstorm with your AI and have it come up with a name, and you can just choose a name, right? So you can brainstorm. I like doing that. I think it's good. There's a lot of other name generators out there that you can use. Startup name generator. That's a good idea. Fun, Sergio. Yeah, exactly, Sergio. All right, let's create get status. Get add. Get status. All right. Vi.get ignore. All right, good. We got no target there. Excellent. Yeah, I'm going to commit this here. -am started our RAG API in Rust. There we go. Easy. Main push. Oh, we don't have a repo yet. We need to make a repo. Let's make a repo, you guys. All right. Create a new repository. There we go. All right, pull this over here. All right, so we're going to call this the Rust RAG API. I like it. It's straightforward. All right. A Axum based API that indexes documents using BM25 FTS and vector search. All right. Perfect. Public. It's a public commit. All right. There we go. We're getting things going here, you guys. And then we are going to push this. Done. All right, and I'll share that on our Discord. See, link share. There you go. All right. Steven, I think for the database, you may want to use a, what is that? A FASI? They have C++ API, sometimes probably made in Rust wrappers. All right. If I'd more of a long-running thing, Postgres is probably best. Yeah. Postgres, if you're going to be doing more, right? SQLite is going to be really fast. It's going to be really fast. I promise. You'll get latencies and sub-millisecond latencies. Now, if you get Postgres involved, you're going to have to do cross non-embedded latencies. And so you're going to have, it's not going to be that much slower, but it will be in the milliseconds instead of the microseconds. So that's what I was going for. SQLite is fast. Yeah, that's right. About the vector extensions. We're going to use Turbovec. All right, Turbovec cargo. Yep, here we go. Turbovec. It is going to allow you to, it's Google's Turbo Quant for vector search. Google's Turbo Quant for vector search. It just came out, I think, this month. And it's real fast. Oh, wait. Hey, you're right. What is this? What is this? I don't know what is this? Facebook AI similarity search. Good. Hey, there we go. PG vector is really good. Is it like a FOSTAs? Okay. So yeah, we're doing the Facebook AI search. right? Facebook AI similarity search. I guess that's what they call it. Mr. Sophos, oh well, one way named something, just call it what it is. Yeah, I know, right? Yeah, that's what we just did. All right, you guys, we got started. We made our plan. We've got our components, and now we just have to write it. So for the next week or so, we'll be focusing on writing our RAG API. RAG API, all cosine and other similarity search. It's all cosine similarity search. You got it. L2. All right, you guys, across some embedded latent space. That's it. That's basically what it is. The issue with Facebook search-based stuff is that it saves to disk. It's somewhat slower. Yeah, it's going to be loaded in memory, and we also save it to disk, so that way we don't have to reload it every time. We don't want to have to re-index everything. So we will save it to disk, and it's still going to be loaded 100% in memory. That's why it's going to be fast. Hey, Null Zero, good to see you. Welcome on in. Good day. See ya. All right, Sergio, we are wrapping up, you guys. We are going to head out now. Thank you so much for joining. We'll be back tomorrow. We're going to finish writing more of our Axum and our API layer. Then we're going to get our model, our embedding model, and then we're going to get our vector store, and we're going to get a SQLite, and we're going to have everything we need. And we're going to have our full RAG engine. We won't fully build it tomorrow. We're going to make progress on it tomorrow is what we're going to do. That's the plan. Thank you guys for joining. We're heading out now. Oh wait, you know our subtitles, they just went away this entire time. I just realized they were gone. Oh well, that's when our browser crashed. All right, good to see you guys. Thanks, that works. Excellent. Expecting 100% in memory fast. Yeah, there you go. Friends, if you want them. Yeah, you got it. Thank you guys for joining. We're headed out now. Thank you, George. Thank you again for another 10 donations. I appreciate it. The 10 gifted. Gemini embeddings or any? Yeah, we could do that. We could do that as well. We could. Bye. All right, Neva. Thank you guys. See you, George. See you, Sofa. See ya, Neva, Null Zero, Sergio, and everyone else. Quick Fix as well. Thank you guys for joining. We'll be back tomorrow. Bye, everybody. See you tomorrow. Have a good one.